have this number n equals to 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190, and we have to check whether it is divisible by 14 and whether it is divisible by 34. Now, before we attempt this problem, there is one important concept that we have to learn, because here you can see that for all of these numbers we have same exponent 190, right? So whenever you have same exponent, then you can use the following concept that we are going to discuss. In fact, there are two concepts. So the very first one is that if I have a raised to n minus b raised to n, where n is some natural number, some positive integer, so this is always multiple of a minus b, right? A raised to n minus b raised to n, this is always multiple of n, multiple of a minus b. N is any natural number, and if n is even number, then this is multiple of a plus b also. And using factor theorem, one can easily prove this result also. So if n is even number, then it will be multiple of a plus b. So a raised to n minus b raised to n, that is always multiple of a minus b. That means a square minus b square, or a cube minus b cube, and so on. They will always have this factor a minus b. And if the exponent is even number, for example, a square minus b square, or a raised to 4 minus b raised to 4. So all of them, they are multiple of a plus b also. And there is another related concept, although not useful in this problem, but in some other problem you can apply, that if I have a raised to n plus b raised to n, so in that case, this will be multiple of a plus b, right? This is multiple of a plus b if n is any odd natural number, right? So for example, if I have a cube plus b cube, or a raised to 5 plus b raised to 5, so then it is always multiple of a plus b. So these are the three things that you should know. Now we can proceed with this problem. The given number is 25 raised to 190 minus 19 raised to 190 minus 8 raised to 190 plus 2 raised to 190. And you can see that for all of these numbers we have same exponent, and we have to find whether it is divisible by 14 or 34 or both of them. Now here, first of all, you can very easily check that whether this number is odd number or even number, right? Because then if I have to check whether a number is multiple of 14 or not, so a number will be multiple of 14 if it is multiple of 2 as well as multiple of 7. Similarly, it will be multiple of 34 if it is multiple of 2 and multiple of 17. So here 25 raised to 190, this will be odd number. 19 raised to 190, another odd number. Odd minus odd will be even. And the other two numbers, they are even number. So that means this given number n, this is even number. And once we have established that it is even number, now we do not have to check for 34 and 14. We need to check for 7 and 17, right? So first we'll check whether this number is multiple of 17, and then we'll check whether it is multiple of 7, because it will be multiple of 34 if it is multiple of 17 as well as multiple of 2. We have already established that given number is even number. Now, in order to check, in order to show that it will be multiple of 17, we can use this first result, a raised to n minus b raised to n. This is always multiple of a minus b. So here let us try to create 17. For that you can combine 25 and 8, right? 25 minus 8, that will be 17. So 25 raised to 190 minus 8 raised to 190. And you can combine the other two terms. That means 19 raised to 190 minus 2 raised to 190. Now clearly you can see that this first term, this is multiple of 17. This will be multiple of 25 minus 8, that is 17. Similarly, the second number, this is also multiple of 17, and therefore their difference is also multiple of 17, right? So this number n is multiple of 17 as well as it is even number. So it must be multiple of 34. That means option B is incorrect. 14 but not 34. This is also incorrect. Now we need to now we have to check for 14. And because we have already established that it is even number, so we need to check for 7. right? So second part of this problem will be, we need to check whether this number is multiple of 7 or not, right? Now, for that one, let us see that if we divide this number by 7, then what is the remainder we are getting? Also, we can combine some of these terms and see which of the above results are applicable here. So 25 and 8, that will give us 17. 25 and 19, if I take difference of those two, we'll get 6. 2 and 8, that will also give us 6, but we need 7. So maybe we can combine these terms. We can write 25 raised to 190 minus 8 raised to 190, and 19 and 2. If you combine these two, 19 and 2, so their sum will be 21. And a raised to n minus b raised to n, this is multiple of a plus b also, if n is even number. So clearly we have even exponent. So if I combine these two terms, 19 raised to 190 minus 2 raised to 190, so then we can show that this will be multiple of 19 plus 2, which means multiple of 21. And if it is multiple of 21, it has to be multiple of 7 also. So we can neglect this part, right? When we divide this one by 7, remainder will be 0. So now we need to focus on this number only. We have to see what will be the remainder when you divide this number by 7. So for that, 25 you can write as 4 plus 21 raised to 190, and 8 you can write as 1 plus 7 raised to 190, and now use binomial theorem. So it becomes 4 raised to 190. All the remaining numbers, they will be multiple of 7, so you can again neglect that one, and then minus 1 raised to 190, right? This we can write in this form. And now we have to see that which power of 2, right, which exponent of 2 is multiple of 7 plus 1 or minus 1. So for that we can do 4 cube. 4 cube will be 64. 64 is 1 plus 63, and 63 is multiple of 7. I'm not writing multiples of 7 here. I mean, the next term will be 190 C1 into 7. After that, 7 square and so on. Similarly, here also 21, 21 square and so on. All of them, they are multiple of 7. So we can neglect that part. Now, this one you can write as 4 into and 4 cube raised to 189 divided by 3. So that will be 63. And 4 cube is 64. 64 is 1 plus 63. So 1 plus 63 raised to 63 minus 1. And now clearly you can see that when you expand it using binomial, you will get 1 plus and then multiples of 63, which are also multiple of 7 minus 1. So finally this number n, this will be of the form 4 into 7n. So it is multiple of 7, and 4 minus 1, that will give us 3. And when you divide this number by 7, the remainder will be 3, which means the number is not divisible by 7 and therefore not divisible by 14, right? So the correct answer will be that this number is divisible by 34 but not divisible by 14. This would be the right answer, right? So you can see that whenever you have the same exponent, different terms are there and the exponent is same, then you can use these three results. A raised to n minus b raised to n, always multiple of a minus b, and if n is even, then multiple of a plus b. And a raised to n plus b raised to n, this is multiple of a plus b if n is odd natural number. So from there directly you can see that this number was multiple of 17, and for 7 we had to use binomial theorem, right? We had to, I mean, for this part we can directly claim that it will be multiple of 7, but for the other two terms using binomial, we established that when you divide that number by 7, the remainder will be 3, and hence it is not multiple of 7. So the correct answer for this problem will be option D.